Question number 13. In an ice cream shop, there is some money in the drawer. After selling 6 ice creams, there are 70 euros in the drawer. After selling a total of 16 ice creams, there are 120 euros in the drawer. How many euros were there in the drawer at the start? So here we have to find out that how many euros are in the drawer at the start before selling the ice cream. So two sections are basically given here. In the first part, 6 ice creams are sold for 70 euros. And in the second part, 16 ice creams were sold in 120 euros. So we will find out the difference first. 16 minus 6 is equal to 10. So let's calculate the difference between the prices of these two ice creams as well. That is 120 minus 70. That is equal to 50. So we can say that 10 ice creams were sold for rupees 50. If we divide 50 by 10, that is equal to 5. So in other words, we may say that the price of the each ice cream is 5 rupees. So we know that in total we have sold 16 ice creams. So if we multiply 16 by 5, that is equal to 80. So after selling 16 ice creams, we got 80 euros. But total we had 120 euros. So we will subtract 80 out of 120, that is equal to 40. So 40 rupees or 40 euros were already in the drawer before selling the ice cream. So option C is the correct option here. Question number 14. The koala ate some leaves from 3 branches. Each branch had 20 leaves. The koala ate a few leaves from the first branch, then he ate as many leaves from the second branch as were left on the first branch. Then he ate 2 leaves from the third branch. How many leaves in total were left on the 3 branches after his lunch? So first of all, we know that there are 3 branches. Each branch has 20 leaves. And from first branch, he ate some leaves. From the second branch, he ate the number of leaves which were left on the first branch. And from the third branch, he ate 2 leaves. So let's suppose Kola ate 15 leaves from the first branch. So there will be 5 remaining leaves. From the second branch, he has to eat 5 leaves because 5 leaves were left on the first branch. So it means that on the second branch, 15 leaves are left. From the third branch, he ate 2 leaves, so 18 are left. Now, if we calculate the number of remaining leaves on 3 branches, the total is equal to 38. We can try different combinations here, but the answer will be same. For example, let's suppose Kola ate 10 leaves from the first branch. So 10 are remaining on the first branch. Then he ate 10 leaves from the second branch because on the first branch 10 leaves were left. So on the second branch, if 10 leaves are eaten, then 10 are remaining. From the third branch, he has eaten 2 leaves, so 18 are left. Now, if we calculate the number of remaining leaves on 3 branches, so the total will be 10, 10 plus 18, that is equal to 38. So option E is our correct option. Question number 15. On a tall building, there are 4 fire escape ladders. As shown, the heights of the 3 ladders are at their tops. What is the height of the shortest ladder? So we have to find out the height of the shortest ladder, which is our second ladder. So what we will do, we will find out the length of the upper part of the first ladder and subtract it out of 32. The upper part of the first ladder is exactly equal to the difference of the third and fourth ladder. So we can subtract 36 out of 48, which is equal to 12. It means the length of the upper part of the first ladder is 12. So if we subtract this 12 out of 32, the answer is 20. So it means the length of the second ladder is 20. So option D is the correct one. Question number 16. Nora plays with 3 cups on the kitchen table. She takes the left-hand cup, flips it over, and puts it on to the right of the other cups. The picture shows the first move. What do the cups look like after 10 moves? So at first move, she just flipped the cup, and after 3 moves, the position of the cups will be like that. Then she will take next 3 moves, 3 more, and at the 10th move, the position of the last 3 cups is equal to our option B. Question number 17. Eva has the 5 stickers shown. She stuck one of them on each of the 5 squares of this board. So that star is not on square 5. Tomato is on square 1 and flower is adjacent to circle and triangle. On which square did Eva stick? So here star cannot come at 5, right? And tomato is on square 1, so we can write T over here. Then flower is adjacent to circle and triangle means it is with circle and triangle. So we can say that flower is in the center of the circle and triangle. If we write flower at 3, circle at 2 and triangle at 4, then we are left with star which will be kept on 5, which is not possible because it was told very clearly the star is not at square 5. So we have to change the places. Flower is at 4 because it is in the center of, or it is adjacent to circle and triangle. So circle will be at 3 and triangle will be at 5. So we have 2 free. So star will be at second square. So option D is the correct option. The position of the flower will be 4. Question number 18. 7 cards are arranged as shown. Each card has 2 numbers on with one of them written upside down. The teacher wants to rearrange the cards so that the sum of the numbers in the top row is the same as the sum of the numbers in the bottom row. She can do this by turning one of the cards upside down. Which card must she turn? So in this question, we have to make sure that the sum of the numbers in the top row and in the bottom row are same. And we can flip only one card out of all. So let's calculate the total of the upper row first, that is 31, and the total of the lower row is 35. So it means there is a difference of 4 numbers only. If we flip our card G, then 4 will be written above and 2 will be written down. As we have added 2 more, like it's 4 and 2 was already in the total, so we will add 2 more. So the total of the upper row will be 33. Now in the lower row there was 4 already, but now we have 2. So we can subtract 2 out of total, that is equal to 33 again. So option E is the correct option. We will flip our G card. Question number 19. The numbers 1 to 9 are placed in the square shown with a number in each square. The sums of all pairs of neighboring numbers are shown. Which number is placed in the shaded square? So we have to fit 9 numbers in the given boxes. So we will start from our smallest number, that is 3. So we will write 2 plus 1 because we know that 2 plus 1 is 3. So 2 will be written here and 1 will be written in the left box. If we change the places of these 2 numbers, the answer will be different. So we have to make sure that 2 is at the right side and 1 is at the left side. Now we will see that 2 plus what is equal to 9 because we have 9 at the top. So we have to make the equation like 2 plus what is equal to 9, it's 7. Then we can see the other numbers as well. Now we have 7 at the top. So we can see that 1 plus what is equal to 7, it's 6. Then 6 is in the box, 15 down, 6 plus what is equal to 15, 9. Then we have 7 here, 7 plus what is equal to 15, 8. 8 plus what is equal to 11, 3. 3 plus what is equal to 8, 5. And then 4 will be written in the last box. Although I got my answer in the start, but I wanted to fill it because sometimes same type of questions come but only the description or the question is different. So option D is our correct option. In the gray box, we will write 7. Question number 20. Mia throws darts at balloons worth 3, 9, 13, 14 and 18 points. She scores 30 points in total. Which balloon does Mia definitely hit? So here we have to make total of 30. So we will just make different combinations. Like 3 plus 18 plus 9 is equal to 30. And 14 plus 13 plus 3 is equal to 30. So 3 is coming in both equations. So we can say that she must hit 3 to make a total of 30. Question number 21. A box has fewer than 50 cookies in. The cookies can be divided evenly between 2, 3 or 4 children. However, they cannot be divided evenly between 7 children because 6 more cookies would be needed. How many cookies are there in the box? So we know the total number of cookies are less than 50 and the number is divisible by 2, 3 and 4. It means the number comes in the table of 2, 3 and 4. It cannot come in the table of 7 because to divide it on 7, we have to add 6 into the number. So let's start from the table of the biggest number, that is 4. 4 ones are 4. It doesn't come in the table of 3. 4 twos are 8. It doesn't come in the table of 3. 4 threes are 12. So 12 is divisible by 2, 3 and 4 all. But if we add 6 into 12, the total will be equal to 18, which is not divisible by 7. So it means 12 is also not our number. So we can try some other numbers as well. It's 12. Then the next option will be 24. Because 12 was divisible by 2, 3 and 4. So I just doubled 12 or I read the table of 12 here. So 12 twos are 24. 24 is divisible by 2, 3 and 4. But if we add 6 into 24, the total will be equal to 30, which is not divisible by 7. Now 12 threes are 36. So we can try this. 36 is divisible by 2, 3 and 4. It comes in the table of these three numbers. And if we add 6 into 36, the total is equal to 42. So 42 is divisible by 7 as well. It means our number is 36. So cookies can be divided into 2, 3 and 4 children evenly. And if we add 6 more cookies into 36, then we can divide them into 7 children as well. Question number 22. Each of the 5 boxes contains either apples or bananas, but not both. The total weight of all the bananas is 3 times the weight of all the apples. Which box contains apples? So in this part, it is given that the 5 boxes are given to us and we do not know that in which boxes we have bananas or apples. But the information that is given is total weight of banana is 3 times the weight of apples. So we can say that as the weight of the banana is more than apples, in the 3 boxes, like box number 2, 3 and 5, there are bananas. So we will add the weight of these 3 boxes. So 5 kg plus 6 kg and 16 is equal to 27. Now, if these 3 boxes have bananas, so in box number 1 and 4, there will be apples. So we will add the weight of box number 1 and 4, that is 7 plus 2, which is equal to 9. Now, according to the information, if we multiply the weight of the apples by 3, that is equal to 27, which is equal to the total weight of bananas. So this combination of these equations are correct. So we can say in option E, like in box 1 and 4, there are the apples is 3. Question number 23, Alina wants to write the numbers from 1 to 9 in the squares shown. Arrows always point from a smaller number to a larger one. She has already written 5 and 7. Which number should she write instead of the question mark? So we can see the arrows. At the start of the arrow, there is a smaller number and towards the head of the arrow, there will be a bigger number. So now we can write 4 over here and we will see the number that is next to 4 is greater, that is 5, that is correct. We can write 1 over here, and we will see that all the numbers around 1 are greater than it. Then if we write 2 over here, that is also correct because head of the arrow is towards 2, that is greater than 1, and as arrow is moving towards the left side, and 4 is greater than 2. We can write 3 in the center, and then we will have to check the sides as well. There is no smaller number in upper left or lower box of the 3 because arrows are heading towards these sides, and the 1 is smaller than 3. So we can write 6 in this box, and then we can check the sides as well. All the numbers should be according to the arrows. So option D is the correct option here. Question number 24. Martin placed 3 different types of objects, hexagons, squares, and triangles on sets of scales as shown. What does he need to put on the left hand side on the third set of the scales for these scales to balance? So we have to see that which we have to put on this side to make the to balance the scale. So let's start from our equation 1. We can see that there are 2 hexagons. So I can write H for hexagon, 1 triangle, and 1 square. T is for triangle and S is for square. Let's suppose the value of my hexagon is 2. So I have to make the same sum on the both sides. So I will say that the sum of the the value of the hexagon is 2, the value of the triangle is 3, and square is 1. Then on the both sides I will have 4 and 4. So I can write all the values here. Now I will move towards my second scale. I have 1 triangle, 1 hexagon on the left side of the scale, and 1 hexagon and 5 squares on the right side of the scale. So now I can put these values in the equation. I know that the value of the hexagon is 2, so I will write it 2 at the place of H, 3 at the place of T, and 1 at the place of S. As there was 1 and 5 was written with it, so 5 ones are 5. Now I will add the numbers. On the left side of the equal we have 5, and on the right side 7, which is not correct. It means the values which I decided for the shapes were wrong. So I have to try different combination here. Let's suppose the value of the hexagon is 3, triangle 5, and square 1. In that case, on the both sides I will have 6 and 6. So I will write the values separately. Now I will go towards my second scale. So it has 1 triangle, hexagon, and on the right side 1 hexagon and 5 squares. If I put values at the place of H, I will write 3. At the place of T, I will write 5. And then at the place of S, I will write 1. So 5 ones are 5. If we add these two on the both sides, I have 8. So it means my second equation is also correct because on the both sides of the equal I have same. So now it is given in the third scale that the weight of the 2 triangles is more than the weight of the 3 hexagons, because you can see the way that the scale is down from the right side, and we know that when we keep something heavier thing on the weight, it automatically comes down. So 3 hexagons less than 2 triangles. So let's put the value of hexagon, which is 3. We have decided it before. And the value of triangle is 5. So 3h means we are going to multiply the value of hexagon, that is 3 by 3. Then triangle's value is 5. So 5 twos are 10. So 9 is less than 10, which is correct because the left side of the scale is less than the right side of the scale. Now what we can add into this 9 to get both the sides equal. So if we add 1 square into 9, or if we draw 1 square over here, then the total will be 10 on the both sides. 9 plus 1 is equal to 10. So 1 square will be added on the left side of the third scale to balance it.